Okay, I'm on number 8, our second proof that we're going to work through together, proving triangles congruent using one of our 5 shortcuts. Hopefully you kind of caught on and you set up this problem before you started my video. If not, pause the video, set yours up so that you've got your picture there, you've got your givens down, and then I'm going to pick up with you and we're going to mark our picture and start working through it. Okay? Marking my picture, I've got AC is congruent to BC. So that would be one pair of sides congruent. At least think that. If you don't like to label it that way, that's fine. Angle 1 is congruent to angle 2. So I do have one pair of angles congruent. And I'm missing my third thing. I could actually say I have 2 right now in terms of my congruences. I could say I have a pair of sides congruent, and I have a pair of angles congruent. I only need 3 congruences. Okay, so I guess the first thing that I'm going to do is probably look and see, there must be something else that I know is congruent that I wasn't told, and I'm going to have to either get from my givens or get from my picture. Okay, and at least, maybe you're not sure how to state it, but hopefully if you're looking at your picture, you can figure out what the third thing is based on how you were working through some in your homework last night and having to mark something extra. The extra thing should be right here, this shared side between the 2 triangles. Okay, in my video last night that I put together, I showed you kind of if you separate those 2 triangles, CD, segment CD, is a side in both triangles. So I literally have to say in my proof that CD is congruent to CD. Okay, and if you look at that statement and kind of remove yourself from the triangles for a second and think back to chapter 2 properties, that should be ringing a bell. Something is congruent to itself. Okay, maybe you need to grab your blue DPPT sheet from chapter 2. If you were thinking reflexive property, you got it. That property that you thought was really stupid when you had to say it before you subtracted something, you had to say things were equal. This is an excellent use and probably the best use we have of that property of why do I need to state something is congruent to itself. I told you I'm going to mark off points in your proof if you do not have 3 congruent statements before you say triangles are congruent. So without you saying this common mistake, students like to forget that. And they are like, well, it's obvious. Of course it's true. You have to have your 3 congruent statements. It's simple. Count them up. Now I've got my 3 congruent statements. Okay? Of course, I'm trying to prove triangles congruent. I want to do as little work as possible. If you're hearing a hissing noise right now, I apologize. They're cleaning in the hallway. Triangle CDA is congruent to triangle CDB. Okay, just want to make a quick note about the order in which I'm naming these. From section 4.3, we should be matching up corresponding parts. So CDA, CDB, I am matching up corresponding parts. Okay, I know that's given to you right now, but tomorrow that will become a key important thing that we consider when we make our congruent statement. And I feel like I might be ready to make that step 3. Okay. But I need to, of course, have a reason for saying the triangles are congruent, and my reason is going to have to be one of my 5 shortcuts. Okay, right here, I'm getting side angle side. If I look at my picture, I'm not getting side angle side. Which one do I use? Hopefully you're saying picture, not the order on the left-hand side, because I could have changed those. We don't have to put both givens first. So that just tells me, hey, I have 1, 2, 3 statements. I've got my 3, and then I look at my picture. And if we come over here to my picture, if I highlight my 2 side pairs that are congruent, they meet right down here. This would have to be the angle that's marked congruent, and it's not. It's my non-included angle. So I'm ending up with my ASS case is what I'm getting. And ASS, we know, we can't put as our final answer. So we either need to say that, hey, the triangles aren't congruent, and Ms. Fisher gave me a trick problem, and there's no way I can do it. Or we need to say, wait a second. ASS works if the 2 triangles are what kind of triangles? If they're right triangles. And if they're right triangles, then I can say it's not ASS, but I would say HL. Okay, let's double check. Could we say that these are the hypotenuses that I prove congruent and this leg pair is congruent? Sure, we could. But I'm going to have to first state that 1 and 2 are both right angled. I have to prove they're right triangles. Okay, so we thought we were done. Not quite. I'm going to bump this down. I'm going to keep this thought of saying HL, and I'm going to figure out, can I actually say that 1 and 2 are right angles? And hopefully you're agreeing. Two angles that add to 180 degrees and are congruent both have to be 90 degrees, and I do have right triangles. Okay, you have a couple options right now. Okay, if you want to try it and then check, that's fine. You could go through the algebra. I'm going to take you through a few of the theorems from chapter 2 that you maybe forgot or never learned. What I'm going to do is I'm going to say that since 1 and 2 are congruent, I'm going to make the jump and say that I know that CD is perpendicular to AB. Based on, right from here, angle 1 being congruent to angle 2, CD perpendicular to AB, I'm concluding perpendicular from chapter 2. Again, reference your blue DPBT sheet. That is my perpendicular adjacent angles converse theorem. If adjacent angles are congruent, and supplementary in this case, or form a line, a linear pair is fine, then the two lines will be perpendicular. Okay, that doesn't get me there, but that gets me pretty darn close, because from there, I think you'll be able to get to the right triangles by saying, if I have perpendicular lines, I have right angles, so angle 1 is a right angle, and of course angle 2 is a right angle. By definition of perpendicular lines. I do need to bump down a little bit more. I've got one more step here. And that's going to be triangle ACD, or actually I'm going to use the order here. CDA is a right triangle, and triangle CDB, right triangle. Definition of right triangle. Okay, we didn't write all of those out. It's exactly what you think of it as. A right triangle is a triangle with a 90-degree angle, or a right angle, and we just said that in step 4. So I can say that the two triangles are right triangles. As soon as I've said that, you now can legitimately go ahead and use your HL theorem, and we really don't need the ASS right now. We can go ahead and make the conclusion. We have our hypotenuse leg theorem, or shortcut. If you want to put shortcut, that's fine too. And we know the two triangles are congruent. Okay, that's probably the hardest one you'll come across in terms of, I know we had to do a little bit of work in here, steps 3 through 5, to be able to use our HL. That's why I wanted to walk you through that one. Okay, don't get scared by the rest of them. If you get totally stuck, skip it and move on. I will point out that numbers 9 and 12, you're going to have to use parallel line. You're given parallel lines. You're going to have to use angle pairs from chapter 3. So find congruent angle pairs to give you some of your congruent statements. And I think you should be just fine. You're going to work through 9 through 15 is your homework for tonight. Actually, I take that back. 9 through 16, I'm sorry, is your homework for tonight. Use the rest of the class, work with a partner, help each other out, and finish whatever you don't get done for homework tonight.